All right, so let's look at paper 2, question number 7. So what have they said? Uh, the following diagram shows how bulbs were arranged as a pattern. All right, so Roman 1, taking the row with one bulb as the first row, write the number of bulbs in each of the first 4 rows as a sequence. All right, so let's do that first. So what's the number of bulbs in the first row? They want us to take the row with one bulb as the first row. So it's 1, comma. They want us to write as a sequence. So let's write using commas. What's the number of bulbs in the next row, in the second row? It is 3. What's next? In the third row, it's 5. And the next row, do a count. 1, 2, 3, 4, 5, 6, 7. All right, so we wrote the number of bulbs in the first 4 rows, in each row as a sequence. 1, 3, 5, 7. All right, what's next? Show that the number sequence you wrote is an arithmetic progression. So how do we prove a written progression or a written sequence is an arithmetic progression? Let's see. So first we'll uh, figure out, or we'll do the calculation for the difference between the second term and the first term. That's T2. T2 means second term minus first term. So what do we get? What's T2 minus T1? That's what's T2, second term, 3. And what's the first term? It's 1. 3 minus 1, it's 2. Now let's do T, the third term, minus the second term. So what's the third term? 5 minus the second term, 3. So 5 minus 3, it's 2. Now let's do the next two terms. That's what? T4 minus T3. So what's T4? 7. And what's T3? Third term, 5. That's 2. So what is an arithmetic progression? An arithmetic progression is a progression which has a common difference. Or if I'm to put it another way, arithmetic progression is a progression which has a constant difference between the subsequent terms. Subsequent terms means the nearby terms, the terms next to each other. All right. So here, when we did the calculation, we have found out the difference between the subsequent terms is a constant. See, T2 minus T1, we got 2. T3 minus T2, we got 2. And T4 minus T3, we got 2. So this fits to the definition of an arithmetic progression. All right. So let's present our answer. We can say there are multiple ways to write the answer. One way of writing the answer, let me write at the top here. T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3. So this progression or this sequence or this progression is an arithmetic progression. That's one way of presenting the answer, or is another way to present the answer. You can say, as per the above workings, we observe that or we can, instead of saying as per the above workings, you can simply say in the above workings, yeah? So in the above workings, we observe that this progression has a common difference. What's the common difference? 2. What's meant by a common difference? When you subtract the subsequent terms, you always get 2. So in the above workings, we observe that this progression has a common difference. Therefore, this progression is an arithmetic progression. Therefore, this progression is an arithmetic progression. All right, so we have proven, or we have shown that the sequence what we wrote is an arithmetic progression.